Welcome back, guys. We're going to talk about polygons and quadrilaterals today. Polygons and quadrilaterals, far less questions on the SAT about this than on triangles, mostly because there are just so many different ways to do triangles. So here you've got some notes. Remember to find each interior angle. You want to do n minus 2 times 180 divided by n, right? This is each interior. Okay, so if I've got a 5-sided polygon and I want to find each interior angle, I would do 5 minus 2 times 180 divided by 5. When you do that, you get 108. So each of these angles here are 108 degrees. Then we know interior angles are supplementary to exterior angles. So if I know this is 108, then these pink angles are both 72 degrees because 108 plus 72 equals 180. And this pink triangle has to have 180 degrees. So 72 plus 72 plus x has to equal 180 degrees. It's as simple as that. You just got to remember that n minus 2 times 180 divided by n formula. That's not going to be on your formula sheet. You can Google or you can look at the top of your class folder to find the formula sheet you'll be given on the SAT. That is not on there usually. So you got to memorize that guy. All right, question number 2. So again, if you don't remember how many degrees every quadrilateral has, you can use that n minus 2 times 180. In this shape, we've got 4 corners, so that's 360 degrees. And in this shape, we've got 4 corners, which also have to add up to 360 degrees. So all of them together, the sum of the degree measures of all 8 shaded angles are going to be all the ones from the pink shape plus all the ones from the blue shape, gives you a total. In irregular hexagons, remember that word regular means all of these angles are exactly the same. Angle 1, angle 2, angle 3, this whole angle, and this whole angle. So if I blow that up just a little bit, this whole thing is going to be from a regular hexagon. So hexagons have 6 sides. So n minus 2 times 180 divided by n, where n equals 6. So 6 minus 2 times 180 divided by 6 is going to give me 120 degrees. If I know this is a right angle, because again, I've just blown this up to be a little bit bigger, the whole thing is 120. This piece is 90. So what is the remaining part? That question mark right there. And 120 minus 90 gives us our answer. So you see how important that n minus 2 times 180 is to find each of those interior angles. And then it's just a trick of figuring out how they want you to cut up the shapes and put them back together again. Because the part plus the part equals the total. Number 4. Oh, we've seen this one before in the right triangles unit. How exciting. All right. So the tricky thing about this one is it's not drawn really to scale, and that's intentional. So the side length is 3. So the total side length is 3, 3, and 3. And then these little pieces are all 1. So that's 1 and 1. That means that's a 45-degree angle or a 45, 45, 90 triangle. So that's square root of 2. And then 1 and 1 because bx and by. So if that's 1 and 1, that's the square root of 2. If this little piece is 1, then actually let's get a green here. This piece has to be 2 and 2, which means this is 2 on the square root of 2. And this is 2 and 2, so this is 2 on the square root of 2. If you add all of those up, 2 square root of 2 plus 2 square root of 2 plus the square root of 2 plus the square root of 2, we're combining like terms. So 2 plus 2 is 4, plus 1 is 5, plus 1 is 6. So that's 6 square roots of 2. is going to be your perimeter for that rectangle. What is the perimeter for the trapezoid shown below? So I've got a right trapezoid, which means if I drop this vertical line straight down, that's going to turn into a rectangle on the left and a right triangle on the right with a height of 24. So if I redraw that right triangle, I've got a 24, 25. This is a Pythagorean triple. If you know what it is, you know what A is, and it's super fast. If you're not sure, then you've got to do 24 squared plus A squared equals 25 squared, and then solve that equation. I think you get A equals 7. So if this piece is 7, 35 minus 7 is going to be 28. 28, and then it's asking for the perimeter. I don't know why, but SAT is crazy about area and perimeter. So we've got 28 plus 24 plus 35 plus 25, and that's going to give you your answer for the perimeter. But the trick is to do that, separate the trapezoid into the right triangle and the rectangle. A lot of people are going to think that that's just a square. That's the way they design the question to lead you to believe that that top base is 24, not 28. So you definitely want to use Pythagorean theorem, Pythagorean triples, whichever way you can do it. All right, question 6 and question 7. Oh, we've seen these guys before too. Question 7 is my nemesis. I hate that question. All right, so we know that we've got a square. So if this is a square, this is 3, and this is 3, and this is 3. It means that these sides are parallel so that ADB, this small triangle, right, and that's our x, is going to be similar to DOE, which is a 3, 4, 5 triangle. You can do Pythagorean theorem if you haven't memorized that yet. And then because they're similar, the red triangle and the orange triangle, we can do x over 3. X over 3 equals 5 over 4. And then we cross multiply and boom. Question number 7. If you've been with me watching other videos, this question has appeared like 4 times. It makes me a little crazy. Ultimately, we know that it's a square, so we know this side is 12. We know this side is 8. We know this is 12 on the square root of 2. And then the question is, what is DE? So the question is, what is this side right here? You can try to use similar triangles. You can try to use Pythagorean theorem. You can try to use a whole lot of things. I think the thing that helps me the most is to draw that other diagonal and then put it on a coordinate plane. So I've done this in other videos, but if you think about angle D being at 0.00, and you think about angle B being at 12, 12, then this intersection, which is not in our original drawing, would be at 6, 6. If you draw in this other line that we have, this point, which is point E is at 9, 9. Okay, so if you know that that's at 9, 9, then you can make another little square right here, which is 3 by 3. So this diagonal, which is what you're looking for, is 3 on the square root of 2, which is your answer. The way I got this 9, 9 was to put it in Desmos. So Desmos not available on the SAT. I am happy to talk about how we think there's a better way to do this problem, but that is the way that makes the most sense to me. I'm really struggling, guys, and that's why I keep putting it on here so we can just continue to have the conversation. Some of these really hard questions, they're going to lead you down a crazy path, and the crazy path for me is this question. I really want it to be a different answer, but the answer is, in fact, 3 on the square root of 2. And I think that does it for us. Oops, I wanted to do that. Oh, nope, we've got one more question. So this last question, we've got to highlight all of our information that we're given. So I've got AB is parallel. Ooh, that came out crazy. AB is parallel to GH. So we've got a parallelogram, right? So we've got two similar triangles. This blue triangle is 5 by 10. And this other triangle is going to be X. And because I know this is 1 and this is 1, this whole thing is 11. So we're going to do X over 11. X over 11. Because the lines are parallel, those are corresponding. So I can do side angle side. I know I can do this proportion. 5 over 10 equals X over 11. I think X equals 5.5 when you do that math. And then I know that this piece is also 3. So 3 plus y equals 5.5. So if 3 plus y equals 5.5, y is what I'm looking for. That's AD. That's going to be 2.5, which I think my answer is. What is the length of AD? All right, guys. That is it for polygons and quadrilaterals. Hope they all make sense to you. I love that this video